Rapid shutdown. Okay, where are we at as an industry? When rapid shutdown came out, sometimes a code has a requirement that nobody can comply with because it's an idea that we want to have, and by putting it in the code, it then requires standards to be changed and requires manufacturers to have the opportunity to produce something. So in today's world for rapid shutdown, is this something that can easily be purchased, easily taken care of? I don't have to like try to make things work?
Absolutely.
Okay, so now I'm going to get going. PV conductors, I'm sorry. PV system conductors on, okay, so we're on or in a building must be controlled, typo there, by a rapid shutdown system to reduce shock hazards for firefighters. I understand all of that. I don't understand exactly what it is, but it's something that reduces the fire hazard. Now, without me guys
Shock hazard, not the fire hazard.
Reduce?
Shock hazard.
Has nothing to do with fire hazard.
Okay, so help me out here. Without me getting into the language, Bill, just talk me out. Okay, I need to have something. What are the components? And are there different types of systems for?
Absolutely, we'll get into the details of those things. And so what we're saying on the high level is that this system, once it's actually, when it operates, it makes the system that might have been a shock hazard less of a shock hazard.
Okay, but watch this. I have a microinverter. We now know what a microinverter is. It's a slang term, little tiny guys connect to each one of these, or alternating current modules or AC module systems. We have 120 volts coming out of that. Does this rule apply to that? The 120 volt circuits?
Sure.
Okay.
We'll see in a minute.
Could I, my rapid, 1 second. If I turn off my service to my power and I have an interactive inverter, it doesn't have the voltage, so therefore the inverter can't be exporting any power. Does that automatically mean it's a rapid shutdown?
Yes, basically, but it'll still get certified as rapid shutdown.
I understand it, but what I'm saying is it'll get certified as a rapid shutdown. So it's a microinverter. It would have to be listed as a rapid shutdown, all those other things. So that's one way. And all I have to do is turn off the service. Well, that automatically turns off the power.
Right. As soon as you do that, you have nothing leaving the array. It's zero leaving the array, and you're very limited to whatever the open circuit voltage is to one module within the array.
Okay. So now I want to go ahead and I'm going to have modules, and I want to put DC-DC converters, and I'm going to run DC to DC converter source circuits, because that's going to be happening up. And I'm not going to put a combiner. So I'm going to have source circuits that's going to go directly to my inverter. If I turn off the utility power, I cut off the inverter, but I still have the 600 volts circuits coming to my inverter. So I guess I have to turn those wires off.
It just depends on the design of the system. And so in the examples we've been given, there are systems out there that automatically shut those circuits off.
No, work my example. I have modules on a house. I'm running converters, DC-DC converters. Out of the converters, the source circuit's going right over to my, DC converters go to my inverter. So I'm running these wires. How do I have to turn the power off of those wires?
That's part of the shutdown system.
Okay, so the power has to come off, because I don't want the guy up on the roof, right? And he's going through the wires. And so now how do I turn that power off? Can a DC-DC converter, how do I turn it off?
So that's all part of the DC control circuit. So.
Well, tell me.
I won't mention any manufacturers'
Tell me names. I don't care. Give me the names.
SolarEdge, they were like one of the first ones to really promote these as a rapid shutdown function, and they have power line signal that reduces the output to 1 volt.
Hold on. How do we get this power? How do I signal this thing?
Okay, it's.
I mean,
so let's go to a high level. And
No. I just in my house.
Yeah.
I just want. How do I turn off the wires? I got 2 circuits to a 5 kW inverter. Can I put? What do I do to?
The inverter tells the circuit what to do. Okay.
Hold on. My 5 kW inverter.
That's right.
Okay. it's going to send a signal
That's right.
to the DC to DC converter.
Yep.
See, that's what I'm trying to figure out.
That's right.
And it's going to say, hey, by the way, we lost power coming in.
So go
we
into
need,
safe mode.
I'm
Go
sorry?
into
Right. We're going to safe mode. We need you guys to turn off.
That's right.
Oh, okay. I got that.
Yeah.
Okay, so hold on. Let me see how I turn it. Now, I have to have an initiating device, right? I have to be able to turn these things off.
That's right.
Main breaker turns off the power to the inverter. It sends a signal up to DC-DC converters. That's right. When you guys were talking earlier, you said, Jimmy, about rapid shutdown when I was in the DC-DC converters.
Yep.
So now, but wait a minute now. This DC-DC converter is going to have to be in bed with this inverter. I just can't be mixing them different ones.
That's
Absolutely.
right.
Because this guy has to signal that guy. Okay, so then I guess they're going to have to be listed to work with certain inverters, and inverters. Well, then if I turn off the service, am I good? I'm done? For
If
that
it's-
example?
If
Right?
it's set up for rapid shutdown, so
Yeah.
end to end, that would absolutely work. And certainly SolarEdge does it, and other products do it.
That sounds pretty easy to me. I mean, I get the DC-DC converters. It kind of gets me my power conditioning what I want to. Worried about a shade getting in there or a tree or something like that. That's good there. Gets me my, the voltage at work, that whatever you call that MMP, whatever. There's a name for voltage at a certain point for current. Get the maximum
power point.
maximum MPP. All right, I understand that. Okay, let's just stop right there, and we'll get more complicated if we can. But I wanted to start something to get an idea of what we're talking about.
Sure.
Okay, so now I know that, here we go. PV system conductors on or in a building must be controlled by rapid shutdown. Is there any voltages? Did I miss something? Is there something in the code about voltages and when this applies?
We'll get into that.
Those are coming. Yeah.
Okay, there we
That's
go.
just the preamble.
Now, there's an exception. Rapid shutdown is not required for ground mounted. Okay, so I don't need a rapid shutdown if it's not in a building. Right?
Correct. But if this exception is specific to situations where you have an enclosure for PV equipment out in a large multi-megawatt field, and a jurisdiction may say, oh, that's a building, you're going to have to put rapid shutdown on your conductors because they're coming into that building. We just want to make it really clear, no, it's not. That's not why we do rapid shutdown.
Rapid shutdown, a firefighter's going to go in a building. We don't know what's going on in this building
That's right.
here. You go out to a megawatt system out there, and we got these buildings with inverters. We know what's inside
That's right.
that building.
Yep.
Okay.
Right.
Control conductors. PV system conductors controlled by the rapid shutdown include, okay, what am I including? PV system DC circuits. Hold on. No, PV system DC circuits, not the circuit conductors that's coming off of an energy storage system, because that's not part of the PV system DC circuits.
Right.
Inverter output circuits originating from inverters located within the array boundaries. That sounds like microinverters to me.
Or it could be an inverter that was on the edge of an array.
Yeah, that's true.
So it could be either one.
Okay, let me read this again.
And this is making it clear. You made a statement a few minutes ago about, does the output of an inverter, does it have to be controlled? And this is trying to clarify, these are the circuits that must be controlled. Any DC circuits that are in the PV system that fall under that category of PV system DC circuits, and then your inverters that are in the array itself, their outputs must be controlled
I missed the part
as well.
located in the array.
Yeah.
Okay, so if you put an inverter inside the array, then you have to have that controlled by the rapid shutdown system. Would that make sense to me? Like, okay, let's not put it in the array? Would that be a strategy?
No, not at all.
Because the inverters themselves can be part of a rapid shutdown system.
That's right.
Yep.
Okay, they're interactive, so that's part of the deal.
The,
All right,
the PV system disconnecting means could de-energize those conductors for you.
right. Okay, you're right. Okay, got that. All right, I understand what conductors now. For the purpose of rapid shutdown, the array boundary is defined as a 1-foot area outside the perimeter of the PV. Okay. If it's within the array, like this thing said, within the array boundary, I have to know what the boundary is. And the boundary is defined as the area 1 foot outside. The perimeter is defined as the area 1 foot outside. Okay, I'm sure the text can be better. I'm
Yeah.
assuming it means
It's Basically,
including the array,
all the solar
up to-
panels and the equipment that is immediate to that array.
and then within 1 foot of the outside. So
Yeah.
let's revise that text a little bit.
And that's why the definition of array that we talked about earlier today.
Oh, because
is
if I'm
in
going
there.
to have a rapid shutdown system, and you said that, we need to know what an array is for the rapid shutdown because we need to know what the array is, and then we got to add 1 foot to that because there are rules requiring, and there are other rules in the code talking about outside the array. Okay, and I understand. Okay, and I'm not sure what that slide is. Let's go to the next one. What's outside the array? Okay, wait now. PV system circuit conductor located outside the PV array boundary, which is going to be more than 1 foot away, right? Or more than 3 feet from the point of entry inside of a building. More than 3 feet from the point of, oh, that means that I have an array on a roof and I have wires going down, I'm not going out. And if it gets more than 3 feet from the point of entry inside the building, must be limited to 30 volts within 30 seconds of rapid shutdown. Okay, well, I don't know about the 30 volts in 30 seconds. All I know is it's going to have to be part of the rapid shutdown system, and the 30 volts in 30 seconds is a listed system that's going to do whatever needs to be done. Okay, got that? The PV system rapid system must comply with one of the, okay, the PV system rapid shutdown system must comply with one of the following.
Now the fun starts.
A PV hazard control system listed for the purpose. This is what threw me off. Is a PV hazard control system a rapid shutdown system? What is a PV hazard control system?
PV hazard control system is a new listing. Okay, it's a certification, UL 3741. The standard has not been finished yet. Okay, it's still being worked on, but it is a new certification to control hazards within the PV array. Okay, and so an assembly that has been certified to this new standard would get this PV hazard control listing. They didn't like the name rapid shutdown, which is fine.
Makes
So
sense.
they just chose a different name, and partly to not confuse it with the overall system, which is the rapid shutdown system. It's potentially a component of a rapid shutdown system that addresses the hazards within the array.
Well, the rapid shutdown system is like a DC circuit conductor. It's like electronic equipment. It's a general term that includes a lot of things.
Right.
But the product itself is going to have to be listed, not as a rapid shutdown system, because that includes initiating devices, that includes all kinds of things. So the PV hazard control system is a product that is listed for the purpose to be installed in accordance with the instructions. Where the hazard control system requires initiation to transition to a controlled state, the rapid shutdown initiating device must perform this initiation. Got it.
Yeah.
Now I understand what it was trying to say. You got to get this product that's to this standard so that you can initiate it with the initiating device for the rapid shutdown, and the combination complying with the code with this product gives you your rapid shutdown system.
That's right. And it's option 1 of 3.
That's 1 of 3?
Option one of 3.
Okay, so this is B21, number 2, okay. PV system circuit conductor located inside the array boundary, which is 1 foot outside the perimeter array, has to be limited to 80 volts within 30 seconds. Oh, okay, so this is not the PV hazard control system that there is no product yet. But if you had one, then that would be one option.
That's right.
And the second option is going to be something that controls the 80 volts to 30 seconds. How do I know that I have one of these? How do I know if I have a 2?
So that's where many people refer to this as module level shutdown. It's not really necessarily an accurate term, but it's the idea that microinverters, DC to DC controllers connected directly to modules would perform this by shutting down their outputs so that the only thing that's left is the input.
And we talked at 80 volts is because we want to exclude the microinverters because these are just the DC circuit conductors off of that individual module. So
and they tend to be lower voltage. And so it's still in this limited to 80 volts, which excludes a few modules that go over 80 volts now. So we have modules that go over 80 volts.
What do you do for those?
They wouldn't be able to use this particular method. They might use the first method. So they may be waiting for the first method to come along.
Oh, so in order to get that other stuff,
Yeah.
We can now double that voltage. We can do all
That's right.
kinds of things, but
Absolutely.
we can't yet because we got to get this done. So the code sometimes is written anticipating technology that's pending. Okay, I got this one. This is talking about the DC source circuit conductors on AC modules, AC module systems, and microinverters. Right? It's talking about those source circuit conductors.
Well, what you just said would get somebody a little anxious there.
Okay.
The AC modules and AC module systems, those DC conductors by definition aren't even part of the code.
Oh.
So don't forget that. So
That's part of the product listing.
that's right. It's part of the
I
product
love
listing.
Bill.
So,
You might get some people a little anxious.
that's right. So,
okay.
so obviously the AC output of those systems has to be controlled, and that we just saw that was one of the
Yeah.
two items that is on the list there. But
Right. And that gets
but
controlled.
the microinverter, the wires coming off the module to the microinverter, absolutely, in order to comply with this, would have to be under 80 volts.
And we talked about that microinverter being listed as a part of the rapid shutdown system. And of course it is because it's an interactive inverter.
Right.
And you know what? First time in my entire life I understand. Might not happen. I might not remember tomorrow, but right now I get it. All right, number 3. PV arrays must have no exposed wiring methods or exposed. Yeah, I saw this. I didn't I have a note to myself on this. What the heck is this talking about?
Embedded shingles.
What's that?
Building integrated systems.
Oh.
So this would basically
Hold on. Let me help everybody understand. A building integrated system. Brian, I don't know, maybe you can pop up 332,
see if I can get it
690,
right now.
dot 32. I think it's 32.
Mm-hmm.
A building integrated system, Brian's going to show you that slide here shortly. That is where they have the part of that roof structure is part
That's a
of the
good
solar
picture of it,
system.
yep.
Okay? Part of that solar system. Now, I've seen some that would look like they. Okay, but I'll wait for Brian to get that picture.
Got it right here.
There you go. Well, that's a building integrated PV system. Okay, it's built into the building.
Right.
So now, let's go back over to my slide. And then Bill, say, PV arrays must have no exposed wiring methods or exposed conductive parts and be installed more than 8 feet from exposed conductor. Okay, I still don't understand this. So
Okay.
now I know what a building integrated system is. I know what this is, and I don't understand. What are you trying to tell me?
This is basically saying it's less hazardous inherently because it doesn't have any metal parts, it doesn't have wires that you can touch, it doesn't have anything, and you're far enough away from, even if you touched a wire, you're a bird on a wire at that point. Unless you can find ground readily available to you, you're still not at risk.
So building integrated systems, as Brian is showing us, these don't need to have a rapid shutdown system.
Well, that one in particular would, but let's just use a more current example. So a lot of folks like to talk about the Tesla Power Roof, which is it's actually a glass module. And so it doesn't have any conductive parts. And there's other companies, CertainTeed has a product. There's other companies that have non-metallic.
Oh, hold on. So we're
roofing.
talking about an array that's
This was
non-metallic,
non-metallic, wasn't it?
Yeah.
right? Not a building integrated
No, there's-
system.
I wonder it.
So if we have an array that's all non-metallic,
Yep.
well then you can't get shocked.
Yeah, there's no conductive parts to shock you physically. The wiring is all concealed. You can't get at the wiring, okay?
Got it.
And so,
That's what the Tesla Power Roof.
yeah, there's the Tesla Power Roof. And
Those
so
are
it's,
actually
that's one example.
So, yeah. Cool, huh? That's
And
cool.
so by removing those metal elements, it makes it inherently safer because it makes it more difficult to get in the circuit. And then to complete a circuit to ground, which is your real concern.
Not the ground, but whatever. Whatever.
Well,
Without, let's just say, let's shock it. Now, my question to you is this, looking at this, I need you to help me. So Brian, let's take a look at that.
Okay.
I'm curious, how do I wire this? I mean, how do I put this in? Do I just plug this into things? Is there like a track and I just plug these things into, and then these tracks have wires at the end of them? How does this work?
every system is different, but they're installed generally like a normal roofing where you start at the eave and you work your way to the ridge.
Do roofers do this or electricians do this?
Well, a specialized qualified person who understands roofing and has been trained to install this product, which would require some skills both in electrical and in roofing.
Okay, so let me see if we can understand. This is number 3, is that right?
This is number 3.
Okay, so let me go back here. I'm gonna go back. I'm gonna do this whole thing again as if we've never done it. Ready for this? Okay. 6912. Rapid shutdown. Okay. PV systems conductors on or in buildings must be controlled by a rapid shutdown system to reduce shock or hazard for firefighters. General concept, trying to reduce shock to firefighters. There's an exception. It doesn't apply to those conductors for ground-mounted arrays that are entering a building. Sole purpose is for the PV equipment. Got that. Don't need to worry about that. Now, the PV system conductors controlled by the rapid shutdown includes, these are the ones I have to control. That's the PV system DC circuits and any circuits, outputs, any inverter output circuits located within the array. Okay, I understand what I'm controlling. And what is an array? Well, we get that 1 foot dimension outside. And then it says, PV conductors located outside of the array or more than 3 feet from the point of entry have to be limited. So this is the part that we're limiting, okay? If they're outside of the array or within 3 feet from the point of entry, limited. And that's B1. And the rapid shutdown must comply with the following. So there's 3 different kinds, right? One is this thing that's not made yet, which is a hazard control system, so we're not going to worry about that. 2 is that you have to design it in a way that the volt is limited to 80 volts within 30 seconds. And right now, it looks like I'm putting DC to DC converters that talk to the inverter is one way. The inverter itself would be a rapid shutdown. Microinverters would be a rapid shutdown system. And then I'm not going to worry about 3, because that's the one that Brian was showing me about the roof things that doesn't have the hazards. I mean, the whole friggin' roof is a solar system. You know what I mean? So we're not going to have a rapid shutdown system when it's already there, and or non-metallic parts, as you were talking about. So basically, I need DC to DC converters interactive with an inverter or microinverters. Is that true?
Well, there's other products too. There's DC relays and things that people manufacturing and selling.
I saw that. Mm-hmm. You put DC relays and you run wires, like low voltage wires or something like that, right? Or
No, most of these are using power line carrier.
They're using power line carriers.
Yep.
Oh, so some kind of relay, but that relay has to be working with something. What is the relay working with? How does it know this DC relay to turn off?
Rapid shutdown initiator.
Oh, just an initiator. Yeah. Oh, so we're just going to put let's just simple it. We're going to put a contactor, press a button, and turn off the DC circuits. Yep. And I locate that at, well, I have to put that.
A readily accessible location, unless it's a 1 or 2 family dwelling, then it has to be a readily accessible location.
No, but I'm saying the relays
are going to be in the array.
In the array, or within 1 foot of the array, or within 3 feet of them entering the building.
They're going to be typically installed at the plug connectors, just like the microinverters and DC optimizers. And so one company, give an example, Generac just bought into the PV industry, and they bought a technology. And basically, the inverter communicates directly with the first contactor, and then that contactor tells all the other ones to shut down.
Okay, so there's other technologies.
Yeah, there's other ways of doing it.
Okay, we got it. All right.
So one other thing I want to make sure we're clear on there, though, Mike, is that on the ground-mounted arrays, and that's why it says the conductors entering the building. You could have a ground-mounted array out in your backyard, and some people are doing this with large areas because they don't want to put them on their roof. They're afraid of fires, afraid of a lot of things. Then once you enter the building more than 3 feet with those DC conductors, even though the array is way out in your backyard, you need rapid shutdown for those conductors as well.
Yep. I have a comment here. Guys, take a look at 690.11 exception. I'm not sure what that's about. How are PV modules leads treated under this exception? Was that the one we already talked about? Where I think we were talking about that. That was the one was in the raceway and a pipe, so we already got that taken care of.
Yeah.
All right. I'm going to go to 690.12c, initiating device. So somehow I have to initiate this rapid shutdown function, right?
So hold on. This person's question right here is the exception is only for PV output circuits. The leads coming off the modules are part of the PV source circuit. PV source circuits are required to have arc fault detection regardless. The only exception in the National Electrical Code to arc fault detection on the leads coming off a PV module are in 691, which we'll cover later, which talks about having a fire mitigation program. So all PV systems that are not part of a large-scale system must have arc fault detection on the source circuits. No exception.
Let me read the rule.
If they're over 80 volts.
Let me go back to this rule. On 6.9.11, PV DC circuit conductors operating 80 volts or greater must be protected by illicit arc fault protection. We talked about that was part of the equipment listing.
But an individual module is not going to be over 80 volts.
Right. Oh, no. No. This is talking about circuits operating over 80 volts.
Yeah.
This is not modules.
That's right.
And then the exception, but
It's
that's a DC circuit, so any circuit. I thought we covered
It's
this. And then,
only for, the exception's only for output circuit.
okay, so now let's talk about an initiation device. For the rapid shutdown, a rapid shutdown initiating device is required to initiate the rapid shutdown function of the PV system. When the rapid shutdown initiating device is placed in the off position, this indicates that the rapid shutdown function has been initiated. So I'm not going to say any more on this right now. Here we go. Service disconnect. So if I open up my service disconnect, I have microinverters. Oh, I turn off the power. I could have microinverters that are listed as rapid shutdown. They'd automatically cut those off. I could have DC controllers that can talk to the inverter that's listed together. That could turn that off. I could have a relay that would be able to sense the incoming voltage, and I could turn that off. Or I could not even have to turn off I could just simply have a push button that is listed to work with the relays, right? Some kind of initiating device.
Not a push button, because that's to say on or off.
Exactly, like I said. Can't use a push button because it has to be on or off.
Could
All right,
be
let's
a
go further here.
mushroom. Could be
So-
a mushroom.
I can use the PV system disconnect, right? I can use the service disconnect. Doesn't matter what it is, that's PV system. A readily accessible switch that plainly indicates whether it's in the on or off position, so you can't be using push buttons. D
You
says...
could use a mushroom switch that's used for things like emergency shutdown at a gas station, things like that. Those devices would be acceptable because they have an on and off position.
1 second. Let's read the language here. Readily accessible switch that plainly indicates whether it's in the on or off. Does it say on or off?
No, they don't indicate.
They don't indicate, well, some do, some don't. There are push buttons that do indicate on and off. So I'm
Find
just
one.
saying, don't rule
Find
those
one.
things out.
Find one. You find it. Find it on the internet
Yeah.
today, sometime.
Motor control on-off buttons. They're out there.
I don't think it's an on-off button.
But anyway, regardless, the focus of this is to say that whatever you use has to be clear, because this is going to be operated by somebody who's not an electrician, and they have to know that it's off. That's the key.
No, it's not a push button, unless it says off, and we don't know if there is such one. Okay, but if there was. Okay, equipment on D. Equipment that performs the rapid shutdown function other than initiating devices must be listed for providing rapid shutdown. Okay. Part 2. So we just got done with whatever that was on the circuits.
One other thing on the initiated, Mike, is that on a 1 or 2 family dwelling, I started to mention this earlier, but it's required to be on the exterior of a 1 or 2 family dwelling.
Okay, so we need to make sure that's in my textbook, Brian. What rule is that, Jimmy?
That's in 690.12C.
12C. Which is it? C1, C2?
It's C, the main body.
So the main body, I'm missing it. If it's a 1 or 2 family dwelling, that initiating device has to be on the outside of the building. What about if it's a commercial building?
1 and 2 family dwelling. It's restricted. That requirement's only for 1 and 2 family dwellings. No restriction.
But where do I put a commercial one?
Again, the switch either has to be within 1 foot of the service disconnecting means, or there has to be a sign telling where it is.
Okay, did I miss that? What rule is that? What section is that? Because we don't have the slides here for that. So find me where I have to locate that.
Okay.
Where does the initiating device have to be located? I know the dwelling unit has to be outside.
Under location, yes.
Because it just occurred to me on a commercial building, have a rapid shutdown. If it's not going to be the service disconnect, and it could be the PV system disconnect, but the PV system disconnect could be inside of a building.
So when we get into signs, we haven't gotten there in marking, 690.56. It talks about the signs that are required, and it requires the rapid shutdown sign. It requires the sign for the rapid shutdown switch, and it says that if the rapid shutdown switch is not located at the service disconnecting means that there has to be notification at that location.
Okay, it's not telling you where you have to locate the switch, but
Right.
it's telling you that the sign is going to have to be at the service equipment, telling you
Yep.
where the initiated device is going to be.
Correct.
That's
if it's
correct.
not at.
If it's not at the service.
That's in
Right.
56. Okay.
So using the northeast example, let's say the firefighter were to make it to the basement to shut off the service disconnecting means at that point, they would also probably get notification at that point of where the rapid shutdown switch was on the exterior of the house, because the requirement would be that it would have to be on the exterior.